AC Verma, Chapter Semiconductors and Semiconductor Devices, question number 90. When a PN junction is reverse biased, the current becomes almost constant at 25 microampere. When it is forward biased at 200 millivolt, a current of 75 microampere is obtained. Find the magnitude of diffusion current when the diode is A. Unbiased, B. Reverse biased at 200 millivolt, and C. Forward biased at 200 millivolt. So you have to have this knowledge कि total current in a semiconductor is effectively diffusion current minus stripped current. Look, I have used the sentence effective current. Effectively becomes diffusion current minus stripped current. Diffusion current is actually contributed by majority carriers, and the tripped current is contributed by minority carriers. So majority carrier current and minority carrier current are opposing each other. That's why the total current actually becomes diffusion current minus tripped current. Okay, what I told, key majority currents, that is the diffusion current, and the minority current, that is the tripped current, they are opposing each other. Effectively it is the case. Okay, so total current. So they are telling us कि the current when it is reverse biased is 25 microampere. The current means the total current. So it is 25 microampere. 25 microampere. So in reverse bias, the majority current becomes zero. In reverse bias, the majority current becomes zero, right? Because it is in reverse bias. So the current we are actually obtained is due to the tripped current. That is the minorities. So this equation tells me that the minority current which will always be there is equal to how much? 25 microampere. 25 microampere. So my new equation becomes total current equal to diffusion current minus 25. Microampere. Why? Because by applying the special condition, the reverse bias condition, I have got the value of tripped current which is due to the minority charges, minority carriers. So I have got this. So in this expression I have put that. Now they are telling some special conditions. Key when it is forward biased by 200 millivolt, the current becomes 75 microampere. Okay, that means total current 75 microampere. It is, now I'm telling it is diffusion current DC minus 25 microampere. So if I put the semiconductor in forward bias, the diffusion current will be how much? 100 microampere. Look, diffusion current is 100 microampere, but the reverse current is 25 microampere. That's why the total current is 75 microampere. So as if the semiconductor is always taking a tax equal to 25 microampere. So if there was no minority carriers, that is, if the semiconductor was pure, intrinsic, no minority carrier, then the total current would be 100 microampere. But as pure semiconductors are not acting, so a microcurrent, a microampere current due to the minority carriers is obtained. So it is actually not helping us. It is decreasing the forward bias current, right? So it is actually the answer of the part C. Okay, part C. Because they have told us कि find the diffusion current in C part. Find the diffusion current when the total current is 75 microampere and it is in forward bias. Now, for A part, what they have told, कि semiconductor is unbiased. Look, always remember, unbiased semiconductor gives zero current. Unbiased semiconductor gives zero current. Why? Otherwise, without using any external source, we would have obtained a current from a semiconductor. So we can use it in different purposes. We don't have to take electricity connection. We could have used that, right? So unbiased semiconductor will not give any current. The total current is zero. That is, in unbiased condition, the diffusion current is equal to 25 microampere. That is, unbiased condition gives us the situation which should be followed by any apparatus to conserve the energy concept. I told you very slowly to understand the meaning. Okay? So diffusion current in unbiased condition is 25 microampere, and this is being neutralized by the magnetic carriers. That's why the total current is zero. Okay? It is the answer of A part. And the B part they have told, if we reverse it, reverse bias it, so what will happen? In reverse bias, what happens? The diffusion current becomes zero, right? Diffusion current becomes zero. So the total current will be what? Sorry, they have just asked the, in reverse bias, what is the diffusion current? The diffusion current is zero. We have told that initially. In reverse bias, the current due to majority carriers, that is the diffusion current, becomes zero. So it is the question asked in part B. So diffusion current in reverse bias is zero. This is the explanation for question number 90.